Hi, my name is John Polarpana and I will be reporting about the birth of calculus by Euler's.
So this is the timeline introduction. Who is Euler's? Number 2, Euler's mathematical notation. Number 3, Euler's contribution of the birth of calculus. So Euler's was born on April 15, 1707 in Basel, Switzerland, and he died on September 18, 1783 in St. Petersburg. Leonhard Euler was a Swiss mathematician, physicist, astronomer, geographer, logician, and engineering who founded the studies of graph theory and topology and made pioneering and influential discoveries in many other branches of mathematics such as analytic number theory, complex analysis, and infinitesimal calculus. Mathematical notation. Mathematical notation created or popularized by Euler's. So E, the base of the natural logarithm, a constant equal or approximately to 2.71828. And we have I, the imaginary unit, equal to the square root of -1. And we have f times x, the function of x as applied to the variable or argument x. And also we have the big Z or sigma, the sum of total of the set of the numbers. And E, B, C are constant such as the side of triangle. X, Y, Z are the variables or unknowns in an equation. And also we have trigonometric functions for sine, cosine, tangent, cotangent, secant, cosecant. And lastly, the pi, the ratio of a circle's circumference to its diameter. So Euler's contribution, birth of calculus. Number theory. Euler's interest in the number theory can be traced to the influence of Christian Goldbach. Christian Goldbach is a friend of Euler's in St. Petersburg in Russia. Most of his work is based on very de Fermat ideas. Yes, because kay si Fermat man namatay, si Euler's may nagpadayon sa mga waniya na dayon nga mga solve o na-develop pa ni Euler's. Euler's P function and Euler's theorem. P function is pi of P is equals to P minus 1. O ang kaning P function is nasa connection of Euler's theorem para makuha nato ang x and y is equals to tx over dy. Euler's formula. Euler's formula is either of two important mathematical theorems of Leonhard Euler's. The first is the topological invariance or C topology, relating the number of faces, vertices, and edges of any polyhedrons. It is writing f plus b minus e is equals to 2, where f is the number of faces, v the number of vertices, and e is the number of edges. If a polyhedron is having number of faces as f, number of edges as e, and the number of vertices as v, then the relationship f plus b is equals to e plus 2 is known as Euler's formula. So this is the example of polyhedron. We have tetrahedron, cube, octahedron, dodecahedron, icosahedron. So I'm gonna show you how to solve with polyhedron with using this shape. So first, we draw the shape of cube. So for the cube, we have F or face, and we have V is vertices, and we have E for edges. So for cube, we have 6 faces. V is equals to 12 and E is equals to 8. Now let's move on to the formula of Euler's. So we know the number of FBE, so let's contribute that. So that is the final answer. And this is the sum of example of shape of polyhedron, and the properties is we already know the faces and edges and vertices of each shape of the polyhedrons. Euler's identity is an equality found in mathematics that has been compared to a Shakespearean sonnet and described as the most beautiful equation. Euler's identity used to show how the constant E, pi, and I are related. So Euler's identity is we have E raised to the power of I pi plus 1 is equals to 0. E is equals to Euler's number, or E is equals to or approximately 2.71828818, and I is equals to the imaginary unit, and pi is the number of pi. Pi is equals to or approximately 3.141596. So Euler's identity, so we all know this, that E is raised to the power of I pi plus 1 is equals to 0. So how to get the Euler's identity? So let's start with this. The power series of E raised to the power of Z. So first, let's do this. E raised to the power of Z is equals to 1 plus Z plus 1 over 2 factorial. Z is raised to the power of 2 plus 1 over 3 factorial. Z raised to the power of 3 plus 1 over 4 factorials. Z raised to the power of 4 plus 1 over 5 factorials. Z raised to the power of 5, and continue na siya kaya wala na siya kahumanon. So now we have Z is equals to I data. So that's why we use Z, because Z is a complex variable. So this is the phase now. E raised to the power of I data and equals 1 plus I of data plus 1 over 2 factorials, and we block the Z with using the I data. So before we continue, let me know first the power of I. I raised to the power of 1 is equals to I raised to the power of 2 is negative 1. I raised to the power of 3 is equals to negative I. and I raised to the power of 4 is equals to positive 1, and I raised to the power of 5 is equals to I. So kung magpadayon na siya, magbalik-balik na siya ng I, negative 1, negative I, and positive 1. So let's go back here. So let's put here about the I data times 2. So why I put that? Because we already know the power of I. So we start the negative 1 because she is the first that we have the negative. So since nagsugod naman ta kay negative 1 ug natunong siya sa I raised to the power of 2, dila ta magsugod sa I raised to the power of 2. So we always think that we start the negative, and that is the pattern: negative, negative, positive, positive. So next ato sa isulat ang mga walay I. So let's start the 1 minus 1 over 2 factorials and plus 1 over 4 factorials data raised to the power of 4. And how I get that? Copy ho na nato ang 1 since minus ang ato ang 2 or negative minus atong ibutang, and copy the 1 over 2 factorials and data raised to the power of 2 and plus. So since ang 4 man ang walay iPod ato po siyang i-plus, so let's copy this 1 over 4 factorials data raised to the power of 4. And the next is minus because ato lang timanan is ang una is minus, das on plus, das on minus. And let's add I because we are all done we don't have I, so sa I na pagtangan ay symbol ng I. And data, and again minus, and we copied the 3, so 1 over 3 factorials and data raised to the power of 3 plus, since ang 5 man ay I, ito po na siya i-copy ang 1 over 5 factorials and data raised to the power of 5. Since we have this answer, we base the power series of calculus, and same siya sa cos, and this is the same also the power series of sin, and we copied the cos and sin, and this is cos data plus I sin data. And this is the phase now. So we have the answer equals to cos data plus I sin data, and we don't get the Euler's identity formula, which is the e raised to the power of I pi plus 1 is equals to 0. To get the Euler's identity formula, we use the cos data plus I sin data. So let's do this. E raised to the power of I data is equals to cos data plus I sin data. So data is equals to pi, and this is the time to change the data is equals to pi because to get the Euler's identity. So this is it. The e raised to the power of I pi is equals to cos pi plus I sin pi. So copy the given. E raised to the power of I pi is equals to 1. Why I get 1? Because the cos pi is contributed by negative 1. And sin pi is contributed by 0 and we don't put that. And I is the imaginary. And that is the answer. E raised to the power of I pi is equals to negative 1.
So if you can look, e and pi is a rational number, and I is the imaginary. So if you combine this all compassion, you will get a negative 1. But we all not done yet because we need to put the negative 1 in the left side. So to get the Euler's identity like this. So since negative man ang 1, pag-transfer na to, mahimo na siyang positive. So the face is now like this. So finally we get the Euler's formula,
Which is E raised to the power of I pi plus 1 is equals to 0.
So that's all. That is the birth of calculus by Euler's. Thank you.